nodes and how many edges are there? Well, there's 5 letters, so that would mean 5 nodes. So that would be 5 nodes. And then how many edges are there? Well, there's 1 line, 2 lines, 3 lines, 4 lines, so 4 edges. Okay, I'm gonna head down now. See what else I can find. Okay, I'm gonna do question D now. Okay, once again, how many nodes and how many edges? So there's 3 letters, 1, 2, and 3. That employed 3 nodes. So that'd be 3 nodes. And then how many lines are there? There's 1, 2, 3, 4, 5, 6, and that'd be 6 edges. Okay. Next one. Part A would have 3 nodes and only 2 edges. Okay, and that is question 3 done. Now, question 4. This graph shows the distance kilometers between 2 towns. Okay, and by inspection, find the shortest route from A to F. Okay, so to get to town C, we have 2 ways to get from A to C. A to C can happen via B, which would be a distance of 10, or it can happen directly from A, which is 11. That automatically takes out this route right here. So this route is gone. Okay, it won't work for us. We could also go from A to D and then D to E, which would be 15. But once again, that's no good either. So what we have is the route A to B to C so far. Now, to go from, so we have the route 10 from here. So 10 plus 6 is 16 to E. All right, if I go down, this current route I'm going is this one here. Okay, and to get to E, I could do 5 plus 13, which is 18, but that's no good because it's longer than 16. So that's gone as well. And now we compare the 2 of them, and now I'm on 16. Now, 2 choices here. You could go 10 plus 10 gives you 20, or you could go 16 plus 2 gives you 18. So we're going to take this route here. So it's going to be A to B to C to E to F. Okay. What is the longest route from A to F, in which you do not visit any node more than once? So the longest route, no more than once. Okay. Let me see. Well, we'll go back again and go through our full system, this time eliminating out the, well, we know that A to B and B to C is a shorter route of 10, while A to C is 11. So A to C is 11. That's the one we're going to choose, this one here. Okay. Now, you're allowed to visit each node once, so each letter can only be represented once. Now, we can also do A to D, and then we can also do D to C, and that'll be 15, which means that the green route is actually a better choice, is longer than the red route, I believe. Oh, A, C, D. Now, the problem with this route is, what I'm thinking is, I have a short route after that, which is the 10 or the 6. Well, if I went a different way, if I did instead, if I did A to C, and then I did, which is 11, then I did C to D, that takes 21 to get to D, which makes a lot of sense, because then I'm going to go D to E, which is an extra 13, I get 34, and then I can probably go E to C, instead of going to 2, I can go back up E to C, which is another 6, and then do C to F, which is another 10, which would be 50, which makes more sense. Okay, so that's good. Okay, next one, complete the following graph. Ali is friends with Barbara. So Ali has to link to Barbara. And Carol. So Ali's also friends with Carol, which means I have to draw a line A to C. She's not friends with David, so there's no line A to D. That line doesn't exist. David is friends with Carol, so that'd be D to C. Was not friends with Barbara, so no, there is no D to B. That one doesn't exist. And Barbara is friends with Carol, which we already have. Barbara Carol is already there, and that friendship is shown. So this is our graph for this question. Okay, so we've completed this question. Now, question 6. Is it possible to bring water and gas to the tree houses without any lines crossing? So water to house 1, to house 2, to house 3. Okay. Gas goes all the way around the house 1, no lines are crossing yet. Gas all the way to house 3. And then finally gas all the way to house 2. That's one way of doing it, which works well. There could be another way where instead of linking the water up first, we link up the gas, because the gas seems to be a bit more central looking than the water. And we can link the water all the way around the house 3. Actually, doesn't need to be that long. There you go. Then we can bring the water to house 1 directly under, and then go all the way under to house 2. And that's another way of doing the exact same thing. Now, happy days. Yes, it's possible because we just did. Now, what about this one here? To 3 houses without any lines crossing. We did that already. Now there's 3 different networks. It's possible to bring water, gas, and electricity to the 3 houses without any lines crossing. Let's start off with the middle one again, which is gas. 1, 2, and 3. Electricity can go straight down, as can water. So I need to get water to house 2, which I'm just after achieving. And then I should probably try and get electricity to house 2. Done. And now trying to get water to house 3 is going to be impossible because I have to cross the electricity line. So my answer is no, it's not possible. Okay, question 7. Find the length of the shortest route from B to Z. B to Z. Okay, let's figure this out. Okay, so okay, I can get to Y using 4, or I can go down 4 and across 13. But I'm going to want to use this route here because that's the quickest way of doing it, which is the 4. Okay, I can get to X, probably 8 is going to be the fastest route. Okay. Now, I could go this way to finish off the red route, which is 4 plus 8, which is 12. But if I look at these, if I look at the 3 and the 4 combined, that'll give me 7, and 7 is smaller than 8. So maybe I should, instead of using that red route that way, I should have done the red route this way. Up and then across again. And what I'm going to get is 4 plus 7, which is 11. And that would be my quickest route there. The other route will take me 12, which would be the 8 and the 4 combined give me 12. So I'm thinking my answer is B, Y, X, Z. Now, question 13. What's the length of the shortest route from C to Z? Okay, now we're going C to Z this time. So, C to Z. C and Z. Okay, I can go a diagonal using this blue route here, and that can get me 9 to get to there, and it's also 9 to get here. But once again, this one's an easy one, I think. I'm going to have to go 3 and 4 to get to Z, or go through an 8, which is no good. So I think this bottom root here isn't going to work for me. So it's got to be the top root. This is going to be 9 plus 4, which is 13. So it's going to be CXZ. Now, deduce the length of the shortest route from A to Z. So A to Z. Well, I think we figured out earlier that the route from B, the route from B to the answer part one, the route from B to Z was like this, and it was a length 11. That was a length 11. And then the last answer we had was from Z to Z, which was a length 13. So, okay, and that was 13. Now, it takes me 6 to get to B. So 11 plus 6 would be 17 if I was to continue on this route and just go, oh, sorry, wrong color. Let's just go this way. But if I was to use the green route and go from A to C, then that would be 18. And this one's 17. So I'm thinking I'm taking the yellow route. The yellow route is going to be 17, and it's going to be A, B, Y, X, Z. Resume. A postman has to start at P at the post office and deliver parcels to Q, R, S, and T before returning to P. What's the length of shortest route by inspection? So we have to go P, and then we have to return all the way around. And we're going to have to go through all the different, we're going to have to go through R. So I'll just highlight the parts we have to go through. We have to go through R, Q, S, and T. What would be the fastest way to do this is sort of what we're getting asked to do here. Now, let's see. All right, P to T or T to P is a distance of 3, and it's the shortest distance of any of them. So look at all the outlets from P. You have 3, 8, 5, and 11. So P to T is definitely going to be one of the lines I use. Okay, so P to T has to be one of the lines we're going to use. So P to T, I'll highlight you in yellow. Now, I'm going to try and avoid this 8. This 8 seems quite costly, and so does the 11 and the 12 seem to be quite costly as well. So I'm thinking is I can go P to T, and then I have a choice between 7 and 9. What I'm also thinking is PR, which is the lowest side here. We could do it incorporating PR because it's only 5, and T to R, which is only 4. Okay. Now, it's what to do after this triangle is the main thing. Now, S, T, P. Okay. Now, see this from T. I have 2 choices as well from T. I could go PTR. So these are the lines I'm hoping to use. Okay, guys, so we're going to try something different here. I'm finding this one a bit difficult at the moment, but we'll figure it out. So you might try and make a list of all the nodes on the right hand side. Okay, so let's go P. Okay, so what I'm going to do is going to write down the all the nodes. So P, Q, R, S, and T. Okay, And what we start off with, and then I write them all down here, P, Q, R, S, and T. And what we're going to do is we're going to write down the costs of each one from going from P. Okay, so P is obviously the one we start off with. So to get to Q is a cost of 8. To get to R is a cost of 5. To get to S would be a cost of 11, and to get to T would be a cost of 3. So this is what brought us here earlier, that we decided that we're going to use T. So T is now used. So we're going to cross off T. Okay. So we chose P to T. Now we're at T. And we're at T now. And we're looking across. And it costs 7 to get to Q. An extra 7 to get to Q. It costs 4 to get to R. And it costs 9 to get to S. And then obviously 3 back to P, which we're not interested in because we're returned to the postbox at the end. So I shall select R. So now I'm going to cross off PQR. I'm going to cross off my R. Okay, so far we've gone P to T. And now we're going T to R. And now we're going to examine it from R's perspective now. Okay, so now we examine it from R's perspective. From R's perspective, we can get to Q in 6, or we can get to S in 12. And I think that's a no-brainer. We're going to go to Q. So that's going to be Q. Okay, so Q will be 6. Okay, and then we're left one way to go now. We're going to go back to S. And then Q to S. It's the only way we can do this. Yeah, best way to go from Q to S is 12. No faster way of doing that. So we go Q to S is 12. And that's S gone, and then we finally want to go S to P. And the fastest way of doing that is up by 11. So we're going to highlight this one here. And now we're good to go. Okay, and we check out my answer. My answer is PT, what was it, PTS, and then I went S to Q. Oh, sorry, I went PTQ. I went PTQ. You rewind the video, I went QS, PTQS, and then I went T and P. I can actually just retrace my steps here. If I go back on the video, and I'll figure out exactly what I did. So it's definitely P to T. So it's T to R. So P to T is 3. T to R is 4. And then R to Q is 6. Q to R is 12. And then S to R is 11. And that actually rounds up to being 36, which means I made a mistake somewhere. Whoop-de-doo. I'm going to try this on myself in a minute.